Hello everyone, welcome to the first in a series of Paddock to Reef conversations hosted by Qd Tropics. Can I just get a check that everyone can hear me okay? A thumbs up from someone?
Yep.
Thank you. All right, thank you very much everyone for joining us this morning. The purpose of today's exercise is to, I guess, take on board some feedback from previous years where we've run Paddock to Reef forums, and I guess the feedback has been that we can always do better to communicate what Paddock to Reef is about. And so taking that feedback on board, what we've decided to do is rather than trying to cram a whole lot of information into a one-day session, we've decided to run it as a series of conversations across Zoom and some face-to-face events as well during the year. So I'd really like to thank everybody for joining us today for this first session. As a first try, this particular event was invite only, but future events will be opened up to a more broader audience. And in actual fact, we're considering live streaming them on Facebook as well to sort of broaden the audience that we can get in contact with. So the purpose of today is to hear from Carl Mitchell, who is the coordinator of the Paddock to Reef program across the entire reef space. And today, Carl's going to give us a high-level overview of what Paddock to Reef is about, and also answer any questions that people may have regarding that. And then future conversations will be based around topics that you actually choose. So we're going to be looking for some feedback from you about particular topics. And we're also going to remain a little bit flexible. So if a report card is released, we'd obviously want to do a deep dive into the report card and what that means for our region. If there's any other interesting topics that come up, we would also be looking at running specific events focused around those topics. So all up, today is going to be specifically about the broader Paddock to Reef program. That includes both cane and grazing, but future conversations will typically be separated between commodities, the purpose being that obviously the topics of interest and the information that needs to flow between the different parties is specific to those industries. So without further ado, I'd like to introduce you to Carl, and we'll be keeping an eye on the chat. So anyone has a question, if you could please raise your hand in the chat function, or if you can't work that out, you could or actually, are we going to be able, if you turn your cameras on, if you want to raise your hand and you can't work it out in the chat function, turn your camera on and raise your hand physically and we will see it and then give you the opportunity to ask a question. Carl does have a presentation to get through within the next 50 minutes or so, but there'll be plenty of opportunity for questions. So by all means, if you've got a question that you really want to ask, jot it down in the chat or raise your hand and you can ask it in person. So thank you very much, and I'll hand you over to Carl.
Very good. Thank you, Rob. As Rob said, I've got a presentation, but I'll keep it very short and try and get the discussion going and be more interactive rather than just me talking to a PowerPoint presentation. So Jade, I'll just share my screen. So as Rob said, I'm here to talk about the Paddock to Reef Integrated Monitoring, Modelling and Reporting Program. Program's been going on since about 2009. And the reason that we monitor and report on the Great Barrier Reef is because it's such an important and high value part of the world. And when I'm talking about the Great Barrier Reef, I'm not just talking about this coral bit right out at the marine interface. When we talk about the Great Barrier Reef, we're actually talking about the Great Barrier Reef Marine Park, which is all of the marine waters, estuarine waters, pretty much from the tip of Cape York down to the Burnett Mary region. And when we talk about the ecosystems, we're not just talking about coral, we're talking about the seagrass, the fish, everything that's in there, the mangrove systems, the sponge communities, some of those less interesting muddy reefs and things like that as well. So it's a highly diverse and really complex and really important global icon. And we're not just talking about that hard coral outer reef, we're talking about everything that's in those waters from the coastline out to the hard reef. So some of the facts and figures, we're looking at 345,000 square kilometres along a 2.6 thousand kilometre coastline, 2,900 reefs, 1,500 species of fish, sharks, rays, turtles, the whole gamut. So when we talk about reef water quality affecting, the Great Barrier Reef, we're talking about everything. We're talking about all of the critters, all of the seagrass, all the vegetation, everything from the coast out to the outer Great Barrier Reef. And it's not in great condition. So this was the 2019 Outlook report by the Great Barrier Reef Marine Park Authority. And basically it said that we were in very poor condition. Back-to-back bleaching events, and if you're watching the news, you would have seen we're looking down at another bleaching event at the moment. Cyclones, crown-of-thorns, starfish, floods, disease. The reef seems to be copying it from various different angles. The other piece of information that we use to get a feeling for how the reef is going and what the water quality impacts on the reef is the Great Barrier Reef Scientific Consensus Statement. The last one we did was in 2017, and we get together a bunch of researchers, scientists, to trawl through all of the technical scientific papers regarding water quality management in the Great Barrier Reef and pull out the key underlying themes and messages from all of that science. I think we're looking at about 2,600 papers we've now reviewed under the Scientific Consensus Statement. And like the Outlook report, that information was pointing to the reef not being in good nick and continuing to be that way for a while. So we are currently undertaking the next update of a Scientific Consensus Statement. We're looking to use some pretty technical scientific review processes to just make sure that we do everything rigorously and scientific in the way that we're doing that review. And we're getting the involvement of the Australian Chief Scientist and the Queensland Chief Scientist so that we can make sure that the information we're generating for this consensus statement is absolutely based on the most current, up-to-date and best quality information. And then that will feed into policy and planning decisions going forward on how we manage the reef. So these, with that consensus statement in 2017, we also did a risk assessment, and the Burdekin region came up as very high priority for sediments and particulate nutrients. So it was seen as a high source of both of those. So there's a number of things going on in the reef, a number of pressures that we're trying to address more broadly. Climate change, land-based runoff, coastal development and direct use, so shipping, fishing, tourism, all of those sorts of things. The area that I'm talking about today and the Paddock to Reef program covers is the land-based runoff. And particularly we're interested in three things: nutrient runoff, fine sediment, and pesticides. So what the nutrients do is that if you've got excess nutrients going into that inshore environment that I talked about before, then you can shift the balance from reefs that favour coral to reefs that favour algae. And so you can start to see algal blooms, you can start to see impacts on seagrass beds through algae growing on them and stuff like that as well. So nutrients tend to lead to high levels of algae in that inshore system. Fine sediments can reduce the light availability to both seagrass and coral, and pesticides in that very close inshore area can actually have direct impact on the different species that live there. So from a planning and policy point of view, the Australian government and the Queensland government have a joint Reef 2050 long-term sustainability plan, which has just been updated in 2020. That was its midterm review. And basically they look at all of the factors impacting on the Great Barrier Reef. So climate change, land-based impacts, water-based activities and international pressures such as litter and other things coming from global sources. And that plan sets up a strategy for the Australian and Queensland government to try and protect the Great Barrier Reef by through rehabilitation and restoration and by reducing those impacts. Sitting under that long-term sustainability plan is the 2050 Reef Water Quality Improvement Plan. And the Reef Water Quality Improvement Plan looks at the water quality elements and how we try and reduce impacts on the Great Barrier Reef. And we do that for all sources of pollutants. So we're not just focusing on ag. It can look like a lot of the focus is on the agricultural industries, but we are looking at urban, industrial and public uses of lands as well in that water quality improvement plan. And a big focus of the water quality improvement plan in recent years has been incorporating the human dimensions of change. Why do or don't people undertake activities that improve water quality or reduce the impacts on those inshore areas of Great Barrier Reef? That can be things like social, cultural and economic values. And one of the big focuses of the latest water quality improvement plan was in setting individual catchment targets. So whereas in previous years, we just had one lot of targets for improving water quality on the Great Barrier Reef for the whole reef, we now have targets for each of the 35 catchments that drain into the Great Barrier Reef. And we're in the process of getting ready to update that plan as well. And we're looking at updating targets, particularly the management practice adoption targets, which are the agricultural management targets, and I'll talk to them a little bit later. And we have an independent review of those being undertaken by Alluvium, and we're looking into the water quality targets, the social targets, the human dimension targets, and the urban targets as well. So this just describes what the water quality improvement plan is trying to achieve. So right up the top there in the purple, we're looking for water quality that can sustain the wonderful values that I talked about in the Great Barrier Reef. And the way we're going to get there is from the bottom up. So working with communities to improve the way that land is managed for water quality, specifically for water quality, in the brown there. And those brown targets are ones that I've talked about earlier that are under review, particularly the 90% of land in priority areas having best management, and the grazing ones over to the right. And in the blue, then we've got the reduction targets. They're the Great Barrier Reef water quality reduction targets. I'll get into the specific Burdekin targets shortly. And then by meeting those targets, we're supporting the things in green: the coral condition, seagrass condition, wetland condition, biodiversity, etc. So that's what we call a logic framework, and that's the plan on the page. Basically, by working with communities, we look to improve management, to improve water quality, to improve ecosystems, to put the Great Barrier Reef in good stead going forward. I was asked to talk a little bit about how the targets are developed and reported. And so we see here the bar, you've got the bright green section at the bottom. That's the what we might call the natural or pre-development load. So that's the sorts of levels of sediment and dissolved inorganic nitrogen that we would have seen before human development that we would expect. And we get that through a range of historical research at coral cores, as well as modelling and other things as well. We set that baseline of what we think is the natural load coming off the landscape. And then the orange bit on top is the increase in load that's come from human development. And we call that the anthropogenic load. And so our targets are only ever targeted at that anthropogenic load. We're not interested in trying to hit into what was natural. We're not trying to reduce the natural load at all. We're only looking at a reduction in that anthropogenic load. So if you see our targeted 50% reduction or 25% reduction, it's in that orange bit on top. And then we report year on year how we're going that year towards the target. And that's the hashed bit at the top. We'll give an annual reduction towards that 50% reduction or whatever it may be. So the way that we came up with these targets in 2017 was we ran the marine models. Well, first of all, we did an assessment of what sort of water quality is required in the marine environment to have healthy seagrass, healthy coral. So what are the levels of nutrients and what are the levels of sediments that would enable those systems to adapt to other changes and to be resilient and to be healthy year on year. And so we did an analysis of all of the various thresholds of where we start to see ecosystems degrade into poorer condition. And so we set those thresholds in the marine environment, and we ran the marine modelling backwards to have a look at what level of reduction in current loads in that orange bit would be required to get us to those thresholds and have us sitting under those thresholds most of the time in order to give the seagrass and coral their best chance. So that's how we set up the targets for the 35 catchments, and this is what they look like for the Burdekin region. So we've set them both as percent reduction, and we've put some load targets in there as well. So in the Ross River, we're looking for a 60% reduction in dissolved inorganic nitrogen by 2025, 70% in Horton, 60% in the Burdekin, and to maintain the load at current for the Don. And so that you can also see those targets for the other indicators, fine sediment, particulate phosphorus, and particulate nitrogen. In the black and the Ross, we didn't have enough data on those systems to actually set confident targets, and that's a process that we're undertaking now, and an update of the targets to try and get some numbers for the black and the Ross. So they're the targets that we came up with 2017, and as I said, in the next update of the Reef Water Quality Improvement Plan, we'll be revisiting these targets. So the Paddock to Reef program that I'm talking about today, actually, its main job is to report against how things are tracking towards those targets. So every report card, we produce a status of how we're going towards those targets. So what sort of reduction are we seeing in those dissolved inorganic nitrogen, fine sediment, particulate nitrogen, and particulate phosphorus. We also have targets around agricultural management, riparian loss, wetland loss, and ground cover, and so we report against those in the report card as well. And the way that we do that is we have this integrated monitoring and modelling program, which monitors a whole range of things, all the way from what happens on farms through to what we're seeing in the marine environment. And we start at the farm end. We have a group in the Department of Agriculture that look at farm practices and what's going on in farm practices, and give us a report year on year to say what they're seeing in farm practices. The way that they do that is every 5 years they go and do a major survey of what information can they find, who can they talk to get a line in the sand that they call a benchmark of where farming practices are for that year. So they may do surveys, they'll go and look at industry reports, they'll try and get fertilizer and pesticide sales data, any information that they can find to set up a picture of what the current state of adoption is for agriculture. And that may be, it doesn't matter how those people got to that current state. It could be through funded program, it could just be off their own back, voluntary adoption. They just take a snapshot of where industries are at that point in time. And then for the next 4 years between those benchmarks, they take data from investment programs, from regulatory programs, from a range of other reporting mechanisms, and they take all of that information on what changes happened each year on year between those benchmark events. And so that way they can build a picture. Every 5 years, they try and capture everything. And then in between, they try and capture the change year on year. And then we have a bunch of scientists out in Paddock doing management practice effectiveness. So they run a range of field trials to have a look at what different practices, what impact they have on water quality. They might use rainfall simulation or side-by-side trials to try and get an understanding of what the key practices are and what their water quality fingerprint is, that they can then feed to the Paddock modelers. The Paddock modelers take the information from agriculture and fisheries to say who's doing what where, and the information from the Paddock monitoring teams to say what sort of water quality signature you can see out of those. And they model that through to see what sort of water quality is being generated from all of the paddocks across all of the GBR. Catchment modelers take that, deliver it to the end of catchment. We've got the ground cover, remote sensing guys, riparian and wetlands, all having a look at what's happening in the ground cover, riparian and wetlands. And then we have a marine monitoring program. So all of those guys in the paddock and catchment side are reporting towards the targets. In the marine, they're purely looking at the condition of coral, seagrass and water quality in that marine environment. So obviously that's a lot to cover in one slide, and I'm hoping to have a decent discussion and tease those various elements out. If you want to get your hands on some of our water quality data, we have a catchment loads monitoring team that monitor 61 sites across the Great Barrier Reef for a range of pesticides, sediments and nutrients, and all of their data is available on the story maps. And if you use your phone and take a scan of that QR code, it'll take you to those story maps and you can do a bit of a deep dive on the water quality for the Great Barrier Reef. So I should point out those guys sit at the end of the catchment here, and they're taking water quality samples that are used to validate that modelling. And we also have a pesticide portal. Looks like the QR code has dropped off that one, but if you search Queensland Government Pesticide Reporting Portal, you'll be able to see all of our pesticide data. As we get it up there, we try to do it as quickly as possible. There it is. There's the pesticide QR code if you want to have a look at our pesticide data. So I might not run through the report card results for 2018-19 unless we have an interest and time for it. And I've been given a few questions about how, particularly the P2R projector tool and how it implements delivery ratios. And we might save that for the discussion as well. But I just wanted to give a quick overview today so that we can start feeding some discussion and have some conversations this morning around that broad suite of things, from why people make decisions around land management, how land management affects the reef and water quality and all of those interactions, catchment management, catchment monitoring, paddock monitoring, all of those things. So I might leave the presentation there and we can start responding to some questions.
Okay, thanks, Carl. So I think overall that's run pretty smoothly. I think Terry is back in after losing her video stream, but everything else seems to be working okay. So thank you very much. There hasn't been any questions posed on the chat as yet, but I guess I'm happy to open it up for anybody who might have a question of Carl. Otherwise, we do have a couple of questions which actually come from previous forums where people have asked questions, and you know, the presenter at the time has done their best to answer them, but we thought some of those questions probably could be followed up with some more detailed responses. So, but I think Carl's done a pretty good job of touching on some of those topics already in his presentation. So does anyone have any questions of Carl regarding?
If not, Rob, we could probably dig into that Paddock to Reef projector tool and the delivery ratios.
Yeah, well, I guess my understanding is delivery ratios aren't just unique to the projector, they're actually part of the entire Paddock to Reef program.
Well, they've
So,
come from our source catchment modelling, which is what we use
so I guess
to.
we'll probably talk about it in the context of the broader program.
Yep, sure.
And how they may, whether there's a difference between the projector and the model as a whole might be another topic itself.
Okay.
Yeah, let's dig in.
I'll reshare my screen then.
In the meantime, if anyone has any questions, they can either put them in the chat or raise their hand. Oh, Angus has actually raised his hand there. So, Angus, I'll come to you in a minute, mate.
And full screen.
So just bearing in mind, everyone, we've got people from the sugarcane and the grazing industry in this session. So we might get some questions that are specific to one or the other. We'll do our best to respond to those.
So in order to determine how much sediment, nutrients and pesticides, or mostly sediments and nutrients, are getting to the end of the catchments, we use catchment modelling, which has been validated against the catchment monitoring. And that catchment modelling uses our understanding of how processes work in rivers and in catchments to generate a load of fine sediments or nutrients at the paddock scale and then deliver that through to the catchment. And it does that through doing lots of fancy calculations through known relationships about runoff and infiltration, delivery to stream, deposition, denitrification, a whole range of different processes that happens when a molecule of nitrogen leaves a paddock, enters a stream, and then is delivered to the mouth of the river. So at the paddock, if you have a look through this diagram, we can have delivery of sediments and nutrients either via surface through channels, drains, and overland flow, or it can be subsurface through groundwater or through lateral flow through the subsurface zone, just basically water moving into the creeks, either through groundwater or through the banks of the river. And in that process, it's losing, some of that's being caught up, some of it's being processed, some of the sediments being trapped, some of the nitrogens being nitrified and turned into nitrogen gas, and a whole heap of other processes are going on. And we've got a feel for how those processes work and the rate that they work in the tropical environments, and the model is basically just replicating that. Once those things are delivered to the stream, we have local stream monitoring sites where we can test our models to say, well, the model, we generated a ton of dissolved inorganic nitrogen at the paddock. It delivered 50 tonnes to the stream. Is that what we're seeing at the stream site? And we can then validate that. And then there's a whole heap of processes from the in-stream site to the end of the catchment. Sediments getting caught and then remobilized, and nitrogen's being processed. It's being taken up by algae. It's being then released as things die. And that's a whole system that's going through, and the model replicates that as well. And then we have our inter-catchment monitoring sites where we're validating those processes in the models and making sure that the answers we're getting are making sense. So basically what these delivery ratios are is how much of that sediment or nutrient is getting from the paddock to the stream. And that's split into two. One's called the surface delivery ratio, and that's the stuff that's traveling by the surface, and the other is the subsurface delivery ratio, which is what's going down through groundwater or through the banks. And then we have a second set of delivery ratios, which is that riverine system delivery ratio, which is what's getting from the stream down to the end of the system. And so they're the two delivery ratios. Basically, we pull them out of the model because the model is actually calculating all the processes, but at the end of the day, you can calculate what that ratio is, how much of it is getting through. The reason that I bring this up in the context of a Paddock to Reef projector tool is a projector tool that we use in the Paddock to Reef program. Well, the projector tool is using the outputs of the paddock models to generate a load at the end of the paddock. And then for our reporting, we need to, for all of our management and for people to have an understanding of how much of it's getting to the end of the catchment, we apply these delivery ratios to get a number at the end of the catchment. So we take the paddock number, we apply the stream, the surface and the subsurface delivery ratio based on the known proportions of how much is delivered from the surface versus subsurface in that area. And then we deliver the, then we apply the riverine system delivery ratio to get that load to the end of the system. So that's delivery ratios. There's no difference between what's in the Paddock to Reef model and what's in projector. The projector one's just taken straight out of the Paddock to Reef model. And that's why when you run projector at your paddock and you get X number of tonnes saved, you're not seeing that full saving being translated to the end of the catchment because we've got these processes of surface delivery, subsurface delivery, and riverine delivery that get taken into account.
Great. Well, that's stimulated quite a few questions, which is great. So, Angus, I'm going to leave you part for a little while because I've got some questions here that relate specifically to the topic that Carl's been discussing. So, Ian Little from Cairns has actually asked the nutrient loads from loss of topsoil from pastoral land factored in, i.e. sheet erosion, not just rill and gully erosion.
Yes, so the catchment model has a hill slope delivery module in it based on the revised urban RULSE, so the revised, sorry, Rob, universal soil loss equation. Sorry, I'm just having one of those mornings. Yeah, so there's a modelling framework that's set up to do exactly that.
Yeah. So yes, so the answer is yes, and there is a model loss for, it's called the hill slope model, and it's a pretty important part of the grazing projector tool, and obviously it forms part of the P2R model as a whole.
Yes,
and that's different to gully erosion, which is run through a separate calculation process called the gully toolbox. So Pioneer cane growers have asked, are the models of loaded paddock, loaded stream and loaded end of catchment checked against actual monitored data? Question?
Yes, absolutely. So all of our models are validated against our monitoring. Yeah.
Right, and I guess the models are really, they are based around the monitoring data that's been collected over the years, and and every single time, even in what would appear to be the exact same situation. So, you know, monitoring also has a lot of variability in terms of its answers, and so modelling actually helps to provide the line of best fit for that data set.
Yeah, I didn't really talk about why we use monitoring and modelling together and not just monitoring. So when we're sticking a bottle in a river and sending it to the lab, we're getting a feel for what's happening on that day and what's happened prior to that point. What the modelling enables us to do is even to look forward and get an understanding of what might happen if we change things in the catchment. It also enables to take out the climate signals, because when it comes to in-stream water quality, the biggest driver by an awful long way is just what the climate is at that time, whether it's raining, drought, whatever's going on. And because our program is really interested in what's a management signal, what can we do to improve water quality if I change this, what do I expect to see? Trying to understand the management signal in all of that climate noise is almost impossible. So the models allow us to take that climate noise out and try and focus in on the management signal. And they allow us to run scenarios to say, well, what if 50% of a landscape moved to this type of practice or whatever? What would we expect to see as a water quality? So the combination of modelling and monitoring give us a much better understanding of how the system works.
Okay, great. So thanks to Pioneer Kangaroos for that question. Now, just continuing on that same train of thought, Bernie from Qd Tropics has just asked: are there any findings changes to delivery ratios of broadacre farming lands away from the coast, e.g., Upper Burdekin or Dawson or the Gower catchments?
Yeah, I think you've got some. I think you've got some modelers coming to talk to you at some stage. They might be better to talk about the nuances of delivery ratios, but you're going to see. Obviously, the further you're away from the coast, more of that entrainment and processing during your river delivery is going to happen. So you're going to see more nitrogen denitrified into the atmosphere. You're going to see more sediment trapped in the. So all of those processes are going to be happening at higher levels a lot further you are away from the end of the catchment. So definitely you will see differences there.
Yeah. Okay. Thanks, Carl. Now, Ian's asked a question about crown of thorns. So I'm going to come back to that.
Yep.
Kathy's just said, so are delivery ratios unique for each catchment, sub-catchment?
Yeah, so basically sediment type, temperature, climate, those processes that are involved in the delivery ratio are basically impacted by a whole range of factors. So depending on where you are, what soil type you're on, what climate type you have, you're going to see whether the level of surface delivery versus subsurface delivery, all of those things are going to impact your delivery ratios. Yeah.
Okay, great. So I'll go back to the question. Actually, I'll go to Angus. Can we just unmute Angus, Jay? Okay. Ask this question. It's too late to type it.
Yeah, I just had a question about the basis of having a 5-year cycle. So what's involved with that 5-year benchmark resetting and why is it that duration?
Yep, that's a great question. And basically, in science and research, people are coming up with new and better ways to measure and report on things all the time. And if we were constantly updating our models, constantly using new methodologies for our monitoring, then any change we see in our reporting could potentially and most probably be a factor of those changes in our methodologies. So we lock our methodologies in for a 5-year period so that any trend or change we see over that time is a result of actual change and not just a methodological change. And we save up all of our changes and implement it once, and we do backcasting to see what the results would have been under the new methodology. And then we move on for the next 5-year period. So we want to be able to tell a story of what's changing, and to do that, we need to have a cycle where we don't constantly change the way we measure things. Okay, great. I apologise if my audio is not coming through too clearly. I've had a message here that says I'm a bit quiet, so I will speak up. So I'm going to go back to Ian up in Cairns. He's asked, how significant is the relationship between crown of thorns starfish outbreaks and algal blooms? And do we believe there's a relationship? Carl, I'm going to refer that one to you. Absolutely. So, as I said, we every 5 years we do this review of all of the science and the current understanding, and this year we're doing a very rigorous review. And the way that we're framing that review is we have these key questions of the science that we're going to ask, and then the researchers get together and they go through all of the various reports and they try and tease out an answer to that question. And the number one question at the top of our list for this upcoming consensus statement is, what's the relationship between COX and nutrients? So give us 10 months and we'll have a much clearer answer on that. Right. Great question, Ian. Thank you again. Pioneer Kangaroos have come back and just asked whether the monitoring data is available for public viewing. Oh, that was that QR code that I gave you for the story maps. So I can make sure that that's available to everyone. We'll share that with all the attendees from today's session. So just to remind everybody that after today's session, this is all being recorded. This recording will be available off the landing page on the Qd Tropics website. We're also going to prepare a summary paper, and that all of that information will be available from that landing page
where you and that'll include all the sessions that we run in the future as well. Okay,
And
so-
in those story maps, at the tabs at the top, there's a download button that you can go to and just download our data,
So
basically.
do you get all that from that QR code?
It'll take you to the story map and then you navigate through to the download section. Yeah.
Great, thanks. So Josh Nichols from Qd Tropics has asked, there's been a number of instances where results of the grazing projector tool differ from some of the water quality science, or I guess the more traditional prioritisation tools that have been used by organisations up and down the coast. So is there any way that you could perhaps explain some of the reasons for those variations? So the projector tool is pointing us towards sediment in certain locations within catchments, and the traditional prioritisation tools have been pointing us to sort of different areas.
Yep. So what the projector tool is doing is it's looking back at our last 10 years worth of paddock modelling. It's got a great big lookup table in the back end. And when you put in your polygon for the paddock that you're working on, it goes and finds the closest soil type and the closest climate file and the closest change scenario to what the scenario that you've put in, and it just pulls up the answer from that lookup table. So it's not the same as actually running the model specifically for that paddock on any given day. So there will be some variations between our modelling results and projector tool because the projector is using a lookup table, but they will be very close and within the order. As far as nuances in different runs and things that people are seeing, I'd have to defer that. And then the prioritisation, I'd have to probably know a little bit more about what we're seeing. But the projector tool very much is at that paddock level. So to do some of the more sort of risk assessment type analysis at that larger scale, we would use other tools, and we're developing a reefonomics tool at the moment that can do that sort of larger scale assessment and take into account other factors such as adoption and economics and those sorts of things. So when you're doing a prioritization, it doesn't just matter where the most sediment's coming from, it's where are people who are willing to work with you, how much is it going to cost, how much of that's been delivered to the end of a catchment, stuff like that. Yep.
Thanks, Carl. Carly from Qd Tropics has asked a question. We often hear from graziers, is there any equivalent modelling of urban impacts on sediment runoff? And are those impacts incorporated into the figures, or are they separated out?
Yeah, so we do model urban in the reef report card, and I'm absolutely not going to remember the proportions, but it's a much smaller proportion of the total runoff that's coming from urban environments, but obviously has a very localized impact. We are currently working on an urban stewardship, water stewardship framework and urban modelling through like detailed, the equivalent of our paddock modelling in the urban environment, and that will be available in the next couple of years. And so we're getting a better handle on what those urban impacts are, but they tend to be more localized. Yeah.
Okay, and Bernie's asked about whether the modelling is attempting to account for the huge difference in delivery to the coast between a series of wet years and dry years, and the expected, differences that climate change might bring about.
Yep, so that's really interesting. As I said earlier, one of the things that modelling can do is pull out some of those climate impacts. So when we run our catchment modelling, we get from the Department of Agriculture guys the layer for what management change has happened in that year, and we apply it to the catchment, and they do that over a 28-year climate cycle. So they're looking at a broad range of really wet and really dry years, and they're taking a lot of that variation out so that they can tease out that management signal that I was talking about earlier. And they do that because we want to know, we've seen this much change in the past year, what has been the impact of that change on water quality despite wet years, dry years, and implement that load reduction immediately. So it might be in the case of nutrients, it could be a 20-year delivery cycle for that change to move all the way through to the system and see it in the monitoring. But we can do that instantaneously in the modelling and say, well, we saw X hectares of change, we saw it out, which means we can predict X tonnes of nutrients reduced at the end of a catchment. And that enables us to sort of make management decisions and then also report how well we're going towards those targets. Otherwise, just monitoring, we'd have to wait 100 years for sediment to pass through the system to monitor a change at the end of the system, and decades for nutrients. Pesticides much shorter.
Right, thanks. There's two more questions here, Carl.
Yep.
Pioneer cane growers have asked, how does the review of the baseline each 5-year period take into account practice change that's occurred prior to that period? So if you could perhaps just explain that more clearly.
Yep. So basically, we have benchmarks every 5 years. And then, so starting from the old benchmark, the team will go and do a range of surveys, talk to industry groups, and do an update of that previous benchmark, basically, and say, well, this is the change we've seen in the last 5 years based on all of the available data, including the reported investment and everything in that period as well. So basically, it's a snapshot in time of what the current understanding of management across the landscape is. So it takes into account all available pieces of knowledge, including past change and stuff. The DAF team have got what they call a spatial wrangler. So they've got a spatial tool of management for the whole GBR, where they can see spatially the levels of management in every single block. And so they can overlay what's reported to them and try and reconcile then if things were reported to have gone backwards or changed or whatever. So there's a really neat way that they can spatially arrange that management over time. Yeah.
So Carl, would it be fair to say that if 1 or 2 growers in the lower Burdekin changed their practices and it wasn't part of a project where it was reported to P2R, that might get missed? But if there was a significant shift, say 5 or 10% of the industry moved from one practice to an improved practice, and it was relatively well known within the industry's agronomic support staff and extension staff, there's every chance that that process will actually pick that change up through that communication process that you talked about.
Yep.
And it would result in a shift in the benchmark.
They're exactly the questions we're asking, basically, of the extension officers and others. What change are we seeing? Yeah.
Okay, thanks. Yeah. Okay, Bernie's asked, what scale is the soil data that's used in the projector tool? Will soil data be likely to be developed at a finer scale soon?
Depends where you are in the GBR catchments. So some areas, particularly intensively cropped areas, have much better soil data resolution than the back of the Fitzroy and other areas where there's big gaps in our knowledge. We have been undertaking a soil mapping project with the Department of Resources. They did a bunch of soil mapping up in the Fitzroy and in Cape York last year, and there is more planned as well.
Cool. Okay. So the chat slowed down a little bit, which is good, and I can't see any hands up. So I guess not surprisingly, there's been some really interesting questions about modelling and monitoring, and there's been some interest in the projector tool and also costs. So certainly modelling and monitoring are going to be a topic for a future conversation, and the projector tool, there's been several presentations recently about the projector tool run by Adam and Emily from DAF. But if there's still strong interest in the projector and questions around it and how it can be used and what tricks of the trade, there's every chance we could run the session on that as well at some point in the future. So, but yeah, the chat seems to have slowed. So we're almost out of time. We've just about taken up our hour. There's a hand up from Terry. So can we hear from Terry if he's got a question?
Yeah, Rob, can you hear me okay? I'm just having some keyboard problems. I can't type. Hey, what happens when a practice change occurs, given that technology is changing so quickly, that an A-class practice actually becomes surpassed? So if a grower's at A-class practice and some new technology or some new information comes about that we see a grower actually take on a new practice that surpasses A-class practice, how does that work to the future?
So a couple of ways, and this question reminds me, but I forgot to get back to the alluvium review of the practice targets as well. So I might try and cover that. But as I said, we have a paddock monitoring team that's going out there and testing practices and looking at their water quality signature. And one of their jobs is to look at these emerging practices and try and get some data that our modelers can use on what is the signature, what sort of water quality improvement can we expect from new and emerging practices. So that's sort of our key mechanism for getting data on those new practices. As far as reporting them and getting them into the frameworks, as I said, there's an independent review of the management practice targets being undertaken by Alluvium at the moment, and they're looking to deliver those recommendations on targets later this year. And part of that is that they're looking at a water quality risk frameworks that the management practice team use to assess management. And those water quality risk frameworks are where sort of it's defined what in the old language used to be the lowest risk practices are defined in that risk framework. And the Alluvium guys are reviewing those frameworks at the moment. So they will be looking at what practices are around and what constitutes a low risk practice. So between the water quality risk frameworks and the updates and reviews of those and the paddock monitoring, we're looking to capture those new and emerging practices and get some data on them and get them into our program.
Okay, just another quick question. So basically, besides the paddock to reef questions, are there any other forms of or lines of evidence that we can use to support a practice?
So we have, so the team in DAF are getting data from the DAF extension program. They're also getting data from the regulations team. They're getting data from industry and from regional groups. So there are quite a number of different data points, sets of data coming in to try and when they're assessing that annual change. So they're getting data from multiple sources. And